Hello everyone. We wanted to find something called the expected value of an experiment. Now we already know that if I take any two events A and B, that the probability of their union will be the sum of their probabilities minus the probability of their intersection. Now, if the probability of their intersection is 0, then it means we say the events are mutually exclusive. There's no overlap. There are no outcomes contained in both of them. So now I'm going to define something called a random variable, capital X, and what this will represent is all of the possible numerical outcomes of an experiment. Let's say there are n of them, of any particular experiment, n mutually exclusive separate numerical outcomes with probabilities little pi, and that would be the probability of little xi. So the probability of this would be p1, p2, p3, and so on, where the sum of all the p's must equal 1. Now with our random variable representing all of the possible mutually exclusive outcomes of an experiment, then we'd say the expected value of the experiment, or simply the expected value of that random variable, will be the first outcome times its little probability, the second outcome times its probability, all the way up to the nth outcome times its probability, or simply the sum from I equal 1 to n of xi little pi. Now let's look at a simple game of chance. You're going to roll a single fair die, and what that means is that each outcome of the 6 faces is equally likely. You're going to pay $10 to play, you're going to roll the die, and if you roll a 1 or a 6, you will win $24. But if you roll a 2, 3, 4, or a 5, you receive nothing. So I'd like to know, what is the expected value of this game? Am I going to make money? Am I going to lose money? Am I going to break even? So if all of the outcomes that are possible, well, let's see, I either win or I lose, but I had to pay $10 whether I won or not. So the $24 means I actually walk away $14 richer, or I walk away negative $10 richer. Okay, those are the only two possible outcomes. In the first case, there's 2 ways I can win, so the first probability will be 2 over 6. In the second case, there's 4 ways I can lose, so the second probability is 4 over 6. So for this particular game, the expected value would simply be 14 times 2 over 6 plus negative 10 times 4 over 6, which we can see is going to equal negative $2, which means on the average I will lose $2 every time I play the game.